Hi dear students, welcome to my channel. This video is useful for 8th standard onwards. Okay, keep watch forward, you will understand very clearly. This is class number 65. The problem is like this. One particle of mass m is rotating in a vertical circle of radius r as shown in the figure. Find the minimum speed of the particle at the topmost point of vertical circle such that the particle remains in vertical circular path. Here r is the length of the chord. See here, this is a solution for the problem. Here, this is a chord of length r and this is center O. The another end is attached with a mass m. So now this particle is rotating in vertical circular path. Vertical, it is okay, like this direction. Okay, it is rotating like this. Okay, about the center O, and radius of the circular path is r. The mass of the particle is m. Okay, now at the topmost point A, here at this point the instantaneous velocity direction is like this. It is parallel to the ground. It is horizontal at this point. This is called topmost point. Okay, at the topmost point we are going to calculate what is the minimum speed. Okay, now we will write the free body diagram for this particle of mass m at the topmost point. Okay, at A, that is here. We will write the free body diagram. Downward force is what? mg due to gravity. Okay, another one also, one more force on this particle downward is tension T in the chord. Okay, now downward force mg plus T equal to mv square by r. This mv square by r is centripetal force, that is always towards the center of circular path. So here towards the center is like this. So that force is centripetal force, that is mv square by r. That is due to mg plus t. mg plus t. For v minimum, for minimum speed at this point, we have to calculate. You know this equation. I want v should be minimum. Mg you cannot change, it is fixed. Due to gravity, mg is fixed, we cannot change. What you can change? For minimum speed, this t should be 0. Tension in the chord should be 0. So for that I am substituting tension in the chord T is 0 here. Okay, for V minimum. Now substitute mg plus 0 equal to mv square minimum divided by r. So m cancel. This V minimum, the minimum speed of the particle at the topmost point equal to under root of g into r. G is acceleration due to gravity. R is radius of the circular path or length of this chord. You understand now? Now I will give you one question based on this. The question is like this. From the previous problem, this problem, if V minimum is at this point, V minimum equal to root gr at A, that is here. Okay, find the speed of the particle at B. Here you have to calculate. Means when particle here it moves with speed root of gr, when it is coming here speed is keep on increasing at this point B. B is the bottommost point. Okay, so here what is the speed you have to calculate. That is an exercise for you. Okay. Okay students, now I will explain to understand the what is fictitious force. Okay, now I am going to board a train which is rest on the platform. I entered the train, I sit on my seat and I kept my luggage beside me. Now train started moving. Train is moving forward direction with increasing speed. As speed is increasing, that is nothing but train is accelerating. After some time, as speed of the train is increasing, I observed my luggage which was beside me. It is moving backside. I wonder, who applied the force on my luggage so that it has to move backside. There must be one force to move an object with some acceleration. Agree? So in fact, when I'm seeing my luggage, no force, nobody applying the force on the luggage, but still it is moving backside. Who is responsible for this force to move my luggage backside? That is due to the fictitious force. Because train is accelerating in forward direction, so this train is accelerating frame. It's a non-inertial frame. Because of that, one fictitious force comes. That fictitious force is experienced by my luggage. Because of that force, it is moving backside. Why it is moving backside? Because train is accelerating in forward direction. Exactly opposite to that my luggage is moving backside. Okay? This you can very well experience it. You can observe it when you're boarding a train and in your journey when train is accelerating. Okay? I hope you understood this. Motion in accelerated frames. Some important points I have written here. Listen carefully. Okay? First one is accelerated frames are non-inertial frames. Example, accelerating train, accelerating truck. Okay? Another one, if you make the observations from non-inertial frame of reference, then Newton's first law appears to be violated. I am repeating, appears to be violated. Actually, Newton's first law is not violated. Okay? Another important point. The direction of unexplained acceleration is opposite to the direction of acceleration of non-inertial frame. Okay? Fictitious force. It is an apparent force due to an accelerated reference frame. Okay? The important points are like this. Fictitious force appears to act on an object in the same way as a real force. Then what is a real force? Real forces are always interaction between two objects. However, and you cannot identify a second object for a fictitious force. This is the difference for a real forces and fictitious force. In the fictitious force, you cannot identify where is the second object. The another fictitious force due to the change in the direction of velocity vector. When you are going in a car with some speed, suddenly one curve came. What happens? You will make the turn, no? That time also one force comes on you. That is also a fictitious force. You got it? Please like this video, share this video and subscribe my channel and tap the bell icon to get the notification for further uploads of my videos.